So the topic today is that STEM is more than coding. Why did I choose this topic? Well, first of all, let's see why we care about STEM. If you look at the typical earnings by college majors for adults 25 to 59, according to the Wall Street Journal, STEM topic is now categorized as one of the highest paying jobs. So I think as parents and as teachers and as teaching institutions, we really care about our kids and students' future. So that's also why if you look at the STEM degrees versus humanity degrees over the years, since 2005 to now, STEM has been growing more or less exponentially, while humanity degrees has been either maintaining a flat or a even downward trend. We're actually going to go back to this a little bit later on because as a STEM expert, I do see that as a potential problem. So jobs of the future are something that we have shared many times within our Bloom info session. But one thing that I would like to emphasize would be something like, for example, cyborg anthropologists, right? So what is a cyborg? Well, all of us are actually cyborgs. We are walking robots because we have smartphones with us. Smartphones enhance our memory and processing power and looking up all the different data and doing graphing calculators on our phone, right? But then why do we add anthropology to it? It's actually the study of how we use phones and how it changes our interaction from person to person, and how, for example, the way how we push or pull news from our phone as a habit has transformed the way we view society, or how safe we feel, or how it changed our voting behavior, right? So a lot of these future jobs are either not named yet, but existing, or already exist, but then in a much smaller scale. So a lot of this will require transformation in the workforce. Why am I qualified, or why do I care to talk about STEM, especially making sure that everyone sort of know that STEM is more than just coding? Well, first of all, I am professionally trained as a computer science and engineer. I have worked more than 10 years in Silicon Valley before I actually immigrated back to Hong Kong. And after I immigrated back to Hong Kong, because of the fact that I actually worked at Lockheed Martin and NASA, I had a secret clearance. And that actually does not allow me to work outside of US in the same industry for 10 years, because I guess that's how the US government sees it, as if your technology is being outdated or not. But what is valuable about that is that while I was working for Microsoft as a program manager, while I was working for Accenture as a web analyst, and while I was working for Procter & Gamble as a logistics engineer, and while I was working as a satellite flight software engineer for Lockheed Martin and NASA, I learned not only technology or STEM and its application, but also how valuable it is to have communication skills. And what does it take for leadership skills? Why are some new hires hired into a special training program while others are overlooked? Later on, you'll see that STEM by itself alone is not sufficient. And STEM being narrowed down into just coding is even a more narrow version or interpretation of all the future jobs that we were looking at just a slide ago. And of course, since I've immigrated back to Hong Kong for over 8 years, I've been teaching this whole time at Baker and Bloom, and now at Bloom Academy. And so I am a Google certified educator. So I think that's how many of you know me, actually. And so as an educator, I'm also very concerned to make sure that schools are caught up to what it really means as STEM. So I mentioned that my role is a program director, STEM program director at Bloom Academy. And that means that I actually help develop not only the curriculum, but also teach guest speaker and as well as do partnerships with local partners, such as farm to table and other activities. So let's explore, first of all, how did we get here? Why do we even have the assumption that STEM is the same as coding? Well, if you look at the left column, that is all the, well, not all actually. If I have to name all the after school education centers that teach coding, it might take pages and pages. But these are only the first few that came up when I Google. And then in the middle column, you can see all the popular websites that has come up, honestly, just in recent years in terms of automating your child's coding learning online, right? And actually, they're not bad. I use some of them myself. The point is that STEM is not only coding, but however, it has been popularized so much in Hong Kong that if you look at the right column, you'll see that the age at which we introduce coding has been continually pushed forward and more forward and more forward. This is kind of scary because I'm also a parent and my youngest kid is 5 years old. And if I am the typical Hong Kong parent who is so nervous about,贏在起跑線, right? We say that all the time. It's in the news all the time. I'd be freaked out because you know why? My kid's actually not doing any of those websites. She hasn't taken Coda Kid. She hasn't done code.org. And it might come as a surprise to you because I am actually, an avid coder and I teach even Harvard CS50 to my secondary Bloom students directly. So why the delay, right? I want you to really think about my personal decision as a parent in terms of when to introduce coding to my kid. And then also later on as the research and data that I'm going to show to you in terms of how I may have formed that conclusion myself. So one of the metaphors I like to use is actually humor. And because it really communicates the idea. So as you can see here, fields arranged by purity. It makes it sound like, anything that's more pure, first of all, it's better. So if you look at sociologists, sociology is just applied psychology. And then psychologists is, and then biologists say that psychology is just applied biology. And then chemists is saying that biology is just applied chemistry. And now, of course, physicists can say that, which is just applied physics. Chemistry is just applied physics. Nice to be on top. Woohoo. But then, of course, you got the mathematician all the way at the end that says, hey, nice to see you guys all the way over there. This is basically what I feel is happening to STEM education in the pressure cooker environment that is Hong Kong. Right, STEM, as I know it, when I was teaching as a Discover E stands for engineering, industry specialist in Silicon Valley. I actually did that for over 7 years when I was staying in Sunnyvale. STEM at Silicon Valley was very different. It's never even just the total or the sum of the subjects. It's more than that. It's actually the innovation that comes along with it. It's that inquisitive mindset, right? It's the fact that it's not, who has the best idea only. It's also how you will implement it. And if your idea is relevant and how you would use technology to implement that idea. So coming from Silicon Valley and coming to Hong Kong, I learned about, education is all about 21st century skills. So of course, STEM is, one of the major supporter of the 21st century skills. But then 21st century skills, part of it is computational thinking. Computational thinking, if you have heard my previous talks, you would know that it's abstraction, right? Algorithm, uh, um, I guess decoding or dividing it into smaller bits. And then also the last bit is actually the programming portion. So you have computational thinking, which actually computer science is only a portion of computational thinking. And then out of computer science, you actually have to learn both hardware, software, right? It's integration, user interface, right? Computer science ethics even, right? Media literacy, all that is actually part of computer science. And then out of that, we extract only coding out of it. And we think, voila, as parent, we can check box. I can check it off. It feels really good to do that checkbox. But why is it so popular in Hong Kong as that concept? It's not only the parents pushing it. Actually, if you go back to the previous slide, you'll remember that education institutions really like to do that too. And that's because it's so much easier to grade students and measure them when you have narrowed a completely interesting, multi-dimensional, discipline into something that you can just use Google Form or Quizzes or Quizlet to just auto grade it for you. And believe me, there are plenty of grading algorithms out there. However, what we do that is true STEM and true coding is that you actually don't need a screen for it, especially for younger kids. I really advise this, as I mentioned before, I have a 5-year-old myself, is that, when you teach your kid how to give directions, for example, right, to go from school to home, and they're looking at a map, that is actually algorithm. They have to give you if then else conditions, right? Like if you see the McDonald's, then turn right. If you see this road sign, then turn left, right? And they have to add in conditions and then directions in terms of what you do, like turn left and then go 3 blocks, right? Or turn right and then go 4 blocks. So that is algorithm. What is decomposition? Well, decomposition is one of the courses that is very popular here at Different Room. It's called Building Your Own Robot. We actually have kids bring in their broken toys. I've taught that many summers. And they can take apart their toys very carefully, of course, and in the process, learning how to take things apart in terms of the procedure. And of course, also working their large and small muscles in terms of knowing how to use the tools. And then in the process, learning how things are put together through decomposition. And then what is pattern recognition? Pattern recognition is nothing more than, for example, when you are playing chess or playing Go, right? We have so many after-school activities that parents sign our kids to, but we actually don't recognize the fact that a lot of times it's actually computational thinking, especially when you're playing chess. It's because when you recognize a certain pattern in your opponent, right, you can actually know what are my next steps automatically. Our human brain actually learn a lot better through pattern recognition and storytelling than by memorizing disparate facts that seems to be not linked when we have dissect them down into just the core stuff that we can grade easily, right? That we can just give it an A, B, C, or D. Because anything creative is hard to give it a grade. You can have a whole debate on that and still not be able to give a grade. So that's why we don't measure it. But not measuring something doesn't mean it's not significant. And having something being measured doesn't mean that it represents the whole. Just like simply because coding is easy to teach, easy to measure, and is a small component of computer science, which is a small component of computational thinking and blah, 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 we feel like we can check the box. But in reality, that small percentage of STEM is still just that small percentage. And I really need to emphasize that. You know, if you think about that coding as like, say, 5% of what STEM really is about, and taking that as a grade, and then assessing our children or our students by that and saying that that's how good you are in STEM, it's like, no wonder a lot of girls don't like STEM subjects, because we have morphed it into something that is unrecognizable even by a NASA engineer from Silicon Valley. It's, you know, if you look at my whiteboard in here, you can see that when I'm teaching computational thinking, it's actually without screen. It's all about those daily examples that help us think in more abstract terms and then later on apply in real life situations. Another thing that is very popular in the education field, at least, is that debate between STEM versus STEAM. And you may be wondering, you know, if I am emphasizing so much about, you know, the broader, beautiful, multi spectrum STEM, why am I not mentioning STEAM? I am. Actually, I think that the A in STEAM is so important that I have a whole slide dedicated for it. And I hope you guys like the acronym, because I have discovered that teachers like acronyms just as much as engineers. So the question here, by looking at all these jobs, which is high paying, however, my question to you is, first of all, are STEM, you know, degrees or subjects the only requirement for these jobs? And I think it's pretty clear for everyone who is a professional that the answer is no. But how are we doing that in school if we know that no, that is not the only thing you need to do? Well, in schools, we're still, well, in schools other than Bloom, of course, is that we still use the checkbox method. Some of you may know me on a personal level and know that I have a son who is 8 years old, who is actually one of the top boy local school in Hong Kong. And guess what? He has STEM too in school. Yes, they do. It's once a week for 45 minutes. It's very educational and it checks the box. But schools, in order to support really the kind of multifaceted STEM that I'm talking about, it needs to be a framework. It needs to be a skeleton that supports all other subjects. Because the way I see STEM is that it is, here's the mission, right? The power of science is more than just a grade, but the accumulation of human discoveries so that we can leverage with technology and engineering to solve very human problems at this moment, for this place, for this generation. And I really want to break this down because it's awesome. This is my info session. The importance of what it means to solve human problems. To solve human problems actually means humanities. It is the reason behind the why. And later on, you'll see a lot of my student projects at Baker and Bloom involve a lot of that, the why behind things. And then for this moment, at this place, for this generation, is important because we want it to be applied. Anything that you apply, you won't forget. Anything that you use daily, you don't have to memorize. And that's how you can make STEM fun, even at home. So here you can see the breakdown of the cognitive skill versus group dynamic and communication that is required for a good STEM program. And then as you can see, in a lot of these teamwork, interpersonal skill, written communication, metacognition, all that actually is supported by all the other subjects. However, neither the other subjects nor STEM can exist by itself alone and still create excellent students who are more than mediocre robots, right? We don't want mediocre robots as our students, because anything that they can program that can be automated, automatically graded, basically you can actually replace it with a computer AI. So in terms of being applicable, current events in science. I mean, kids right now are still in Hong Kong. Unfortunately, we're still involved in, immersed very much in the COVID-19 pandemic, right? So as early as in February of 2020, I've already started teaching from a local artist. See how art is involved in here, art and communication, on how germs in general spread, or germs and viruses in general spread. And the coolest part about this artist's rendition of it is it's the fact that it actually has abstraction in it, right? In order to take a really complicated scientific concept, such as COVID-19 and how it spread and things like that, and abstract it into easy to understand words that kids as young as 4 years old can start flipping through and understand the concept, that's abstraction. So I challenge parents at home, whenever you had an exciting day that you had spent with your kids, ask them to retell the story. That is actually computational thinking. Retelling how your day went, going it sequence by sequence, emphasizing the important part, that's abstraction. Telling it in sequence, that's algorithm, right? Giving certain directions on how that day happened. Again, that is decomposition. So as you can see here, another thing that I emphasize in here in the current events is also that parallel thinking, right? Thinking about what I know now, what I know in the past, and how I can make that connection. That lateral thinking is the reason behind STEM being integrated with all the other subjects, as well as STEM as a framework. Lateral thinking is the only thing that we know for sure that robots cannot do. And that will increasingly become more and more valuable as we go through life. And of course, the crazy thing is, how will life be in terms of job seeking for our kids 10 years from now, 20 years from now, right? We have to make sure that they have all that creative thinking, communication in their collaboration as part of their skill set to go along with STEM. In here is another example of STEM that is integrating science, current events, field trip, which is basically learning in Hong Kong, as well as technology. Because later on, they actually have to do a report about it. And my daughter actually designed a map in terms of what they did in that whole day. So this is one of the field trips we've had at Bloom Academy, where we went to the China Tower, where there was a current event where there were wild boars that was actually swimming at the pond there. And this is investigative science. You can think of it that way, right? So they were taking on the role of not only students, but detectives. And think of how much more fun that is as a learning process for science than just always having the role of a student. Wow, you're being a detective today. You're also going to interview some of the guards there. So you're also a journalist, right? Later on, you're going to write about it. So there's communication skills involved. And even to this day, my daughter, who's in the pilot program, is still telling me the story about how they discovered this gap in the fence in the peak, in the park in the peak, and then how they were trying to see if they will fit in, and then if they fit, will the boars fit? To me, when she's telling me that story, it's actually math. It's ratios. It's about what is my size compared to what I know of wild boars. And if I judge that me as a 5-year-old size is pretty close, so does that mean if I can fit through, then the boar can fit through, right? So she's actually thinking mathematically without using a worksheet. Again, math worksheets only measure a very small percentage of what we do. So as a fun break, but also to bring in the importance of communication when it comes to STEM, I invite you to read this comic. I think it's pretty funny. So the key thing about this is that it does have a more hopeful perspective, right? And I think as parents, we always have a lot of anxiety in terms of, am I introducing too much screen time to my kids? Is my kids only learning how to communicate online chats and don't know how to really make interpersonal connections? And as a STEM program director, I can definitely tell you no, that is not true. However, what is important is that the kind of STEM that you sign your kids up, the quality, the holistic approach does matter, right? I mentioned earlier that I do use a lot of the websites online for teaching some of my students, such as Code Combat or Scratch. However, the difference is that I combine it with something in real life, and I use technology mainly as a way of applying their knowledge. So they learn, for example, in a real life environment on how does penguins, for example, live, right? And what are their habitats? And then I have the students then use Scratch to code a game that actually emulates the environment of the penguin and have it catch the kind of food that the penguin can eat and have the fish or the octopus or different things swim at the speed that they have learned. So this is what true STEM learning and project really means. In here, I mentioned about acronym. So STEM without help is helpless. And HELP stands for history, economics, literature, and philosophy. Again, this goes back to the same message I had before, that having the why behind STEM sometimes is even more important than the STEM skill itself. Because when there is a will, there is a way, right? So I completely encourage parents to let your kids run as far as they want on the things that they love. And then see where they can go in terms of applying that using technology, engineering, math, and science. So one example of how far a kid can go with his passion is he's very concerned about the water, the quality around Hong Kong, and how that is affecting marine life, specifically in Hong Kong. So think about it. The reason why he's passionate about it is not because he come to me and say, Miss Mei, I want to do a STEM project. No, it's because he's concerned about marine life. Marine life, while it's about biology, it's also about conservation. It's also about humanities. It's how humans interact with our environment. So the passion and the why behind his project is very much in help. However, how do we solve that problem? Let's break it down. Use decomposition, right? Let's see what are the ways that we can help guard our oceans in Hong Kong. Well, number one, we discovered is that we actually have no cheap way of measuring water quality in Hong Kong. There are a few sensors here and there stationed by the government, and many of them are by universities, right? That has data that is not accessible to the average Hong Kong marine loving population, right? So then we had to design something that is super cheap, where we can get the parts from Taobao. 點解要用淘寶呢？因為夠平 but also 係一個學習嘅過程。因為學識用淘寶 is introducing you, the student, to an entire shopping and media literacy sort of experience that is in the Greater Bay that Hong Kong belongs to. So we've been ordering parts from Shenzhen, just across the border, and then comparing those, Tobo parts with the real parts. That's from Arduino. And then saying that, hey, in the middle picture, you can see, hey, are the two comparable? Can we use it, right? That's analytical skill. Did we fail in a lot of the tests? Yes, of course. But did we persist? Yes. Why did he persist? Because of his passion. The passion that's built within the humanities and social studies and love of Hong Kong as his home. Right? And then, of course, it continued flowering from there, where we had written a documentation and collected data from different oceans within Hong Kong, to the point of where we can then apply for a patent, because of basically using parts that are not typical and very cheap. Another thing I want to mention about STEM is its importance in communication I mentioned before, but in terms of personal data and media literacy. So here is another joke as a break time for us to, so what is personal data? To be honest, I don't really know what it is. I mean, I understand the idea and know it's a thing I should protect, but it's so abstract. Yeah, it's like the economy. I don't really know what the economy is. If we're getting specific, I know stocks are going up, and that's good for people who own stocks, at least, whatever stocks are. Yeah, or taxes. Everyone talks about taxes. What are they? Do I have to pay them? And to who? Okay, wait, you definitely need to learn about that one. Yeah, ideally sometime in like the next few weeks. What I love about this cartoon is that it illustrates two things. Number one, the importance of communication. And number two, the lack of communication in terms of emphasis in STEM. If you think about the scientific community and all the fake news that's going on and misleading information, for example, even COVID-19 and vaccines, right? Recently, we've always had lots of news that comes out saying that this many hundreds of thousands of people has been vaccinated and this many people has died. And then everyone's freaking out. It's like, don't get vaccinated, you'll die. But then that is poor communication. It's twisting the data, because number one, the first wave of people who get vaccinated are elderly patients, hospitalized patients, people who are in elderly centers, right? So if you actually, just on a normal year, in terms of the rate of death in that population, it's already there and existing. But when we make communication of data like that, and we don't teach our students what it means to have controlled versus experimental data, then it's so easy to believe the data itself. It sounds so scientific, right? It's math, it's data. However, first of all, the collection was wrong, right? Secondly, is that the scientific method was actually not used. You have not compared it with a control set. a control set of population with the same age range within the same period of time and their death rate with the group of population of people who got vaccinated and the rate of death and within the same group of age group. That is scientific method. That is real comparison. That is an application of STEM in real life. Another thing I mentioned before is about scientific engineering method in my previous Bloom info sessions. And this is where I think communication also comes in. The kind of vocabulary we use when we're talking to our kids really help them in terms of, are they going to continue to keep trying and persisting and building that grit that we Asian parents keep saying that we love, but then keep beating up our kids when we get it wrong, or ranking them in public schools to discourage them from trying harder. The vocabulary from engineering is something that I love to introduce, and we have been introducing at Bloom Academy. So instead of calling something as a failed experiment, you just call that new sets of data to analyze, right? Instead of calling something as a failed test, you call it a prototype. Instead of calling something as a mistake, you call it as a design feature. I know a lot of computer science engineers actually use that one. So vocabulary, in terms of using different connotation involved in it, it's part of STEM education because it's STEM communication in a way that help us see STEM as what it is in terms of its applicability, in terms of how it's everyday process. And then in here, in this specific student project, you notice that there is also the involvement of help again, right? In terms of the reason why she decided to use recycled material to design her boat, right? The fact that her propeller is actually made from the bottom portion of a water bottle is creative and inventive, and something that definitely robots cannot do. And then in terms of what it means as parents as well as teachers, it's very important that you don't grade on how well the end product looks, but what she has learned in the process. So looking at the right side, see how she outlines all the problems that she has encountered. So in a normal, local school, that might be called failures because she didn't follow instruction, because she didn't use the component that come with that set for this specific experiment, because she didn't follow procedures, right? However, in real STEM, in innovative STEM, in Bloom STEM, it's actually opportunity for learning, opportunity to redesign, opportunity to experiment more, to collect more data, to create a newer model, to compare and contrast with the existing data set. And that's why in our Bloom info session, we also emphasize a different thing that I don't have in here. It's basically ECS, our learning cycle. I think I have it as one of the backup slides in here. So basically, this one is basically where we actually do all the reflection and sharing after each learning cycle. So that compared to what we had before in here, doing the prototype does not mean that you got your grade. Actually, it's learning from your prototype, solving it. That's how you get your grade. So the emphasis is in trying more things, making more mistakes, and really just learning from failure. That's what truly STEM is. So I hope that illustrates our concept, and I am now opening up the floor to questions, and also if there are any content that I have not covered, please let me know. And in here, you can see that I have shared our info session in terms of if you want to hear more how STEM is being applied in the school environment. And I think STEM being applied in the school environment and integrated is more important than only doing STEM outside of school. Because, for example, we will have students learn about 金木水火土 along with the planets, along with the radicals for Chinese. And then later on using VR goggles and zooming in to really feel the distance between the sun and the planets, and traveling and experiencing that duration of time when you're zooming at the speed of light year. And students experiencing that it takes 8 minutes for the sun's light to reach Earth, and actually experiencing that, it's pretty cool. And having peers to do it together is even better. So for example, doing that, chess that I mentioned before, and breaking it down and highlighting the computational thinking skills involved, that is unique and important. Sorry, I will try and go look at the chat now. Let me bring back.
Yeah, Mei, this is Min. I can help read the question. It's from Winnie. Can you hear me okay? Yes? Okay. Yeah, so Winnie has a question for you. How would you suggest teachers who are not majoring in coding or computer science to add STEM elements in other subjects like Chinese or English in the classroom or online teaching?
I think for teachers, number one thing is have no fear. I have a slide before where I mentioned, I don't have it in here because I have too many slides in the data bank, is that we are digital immigrants. And so a lot of times we are afraid of using all the latest tech, Snapchat and Instagram and Discord server and all that stuff. And, when we're afraid of using their tools, it's very hard for us to convincingly say that, I can allow you to do media literacy using your Discord server as a way of finding out how communication has evolved over time when you're chatting online. So I think number one is first of all, don't have fear. Number two is to let your student take the lead. I oftentimes tell my students that I am not only a teacher, I'm more of a coach, right? Because now the entire internet is really the real knowledge base of humanity. And no single person, even a NASA scientist, can say that they know everything, and they shouldn't. And whoever that says that they do know everything is, sorry, completely wrong, right? So having that sense of willing to not be the expert, willing to say that I don't know the answer, but then let's find out together. And allowing, for example, in Bloom, we also allow mixed age teaching. So we have Bloom secondary students who actually created projects about the four Chinese great inventions. And then she actually went to the primary school to go and teach and created a whole website about it. So that is actually teaching how to moderate that learning process, asking the right questions at the right time, helping your student to pace, saying that, hey, you got all these data from Discord. Let's pause now. Let's now use traditional method and analyze all your data, right? Let's draw a mind map on a piece of butcher paper, right? So that you can see how the communication morphed from A to B. That is what a teacher brings. It's our pedagogy, our method. the platform can be digital, and don't be afraid to let the student take the lead on that. But telling them how to pace themselves, how to use questions and answer to lead them to where they want to be, that is the teacher's role. And for example, we also have other lessons where we're learning typing in grade 1, because it's important to learn typing before you actually learn flying fingers for iPad. So while we're learning typing, we're also learning pinyin. And then as language teachers, the pinyin is compared with the phonics of English. So while they're paying attention to the placement of the keys, because they're like 自己, Z-I, J-I, things like that, they are also paying attention to the location of the keys. And the funny thing is, I actually give my daughter a keyboard that is not plugged in and has no power, and just let her play that as her practice. And fun fact, she enjoys it. What's the next question? Sorry, I can't see the question when I'm on full screen.
Yes, so the next question is actually from Rita. She asked, she got the idea that coding is just a small part of STEM, but are you suggesting that it's bad to let kids learn coding too early? So I guess you have to define what is too early.
Yes, I do have a definition for that as a parent and also as a engineer. As a parent, I don't like too much screen time, just because you can tell it changes a kid's behavior, and you can observe that without any research, right? As an engineer and teacher, there are plenty of data that actually backs up, that says that if you introduce screen too early, especially before the age of 6, it actually has significant effects on the human brain development and their eyesight. We call that our eyes is one of the most underdeveloped organ or sense as we are first born, right? I mean, it's actually not until post teenage years that your eyes actually get set, right? So I'm wearing glasses because I was, reading too much in my teenage years. So now I have to wear glasses for the rest of my life. But then this did not form until my teenage years. So how our eyes can see and how much stimulation they get from natural lighting is affected by the screen. And then secondly, how much our brain gets stimulated by the screen in terms of refresh rate is very important. My kids do watch TV, but I make sure that they watch National Geographic, Discovery Channel, things that doesn't change frames too frequently. Like any of those like fast action cartoons, while it's super fun for the kids to watch and even fun for adults to watch, it works differently on the kid's brain. Because every single time that it changes scene, it's a ding to our brain, right? So every single time the cartoon changes scene, is ding, 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 ding. And that's also why our brain is able to keep our attention there so much easier, because it's just like if you're in a classroom and the professor is lecturing, someone opens the door and comes in and everyone looks. Well, is that random person who goes to the toilet very important to pay attention to? No, but it's our evolutionary trait to pay attention to changes. So if we have trained our kids' brain to keep getting used to that ding, 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 well, when real life doesn't give you that ding, 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 then they lose attention. And then that's also why over time we have noticed an increase on ADHD and attention deficit disorder and all that stuff. It's because we have trained our kids' brain to be calibrated to the point where if they don't get the constant frame changing, ding, 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 they have a hard time holding their attention. So that's number one. Number two has to do with coding. I do agree that computational thinking is important to teach early on because it's an attitude and it's a problem-solving skill. However, teaching it only online, like sort of like be the lazy parent and give them like scratch junior and then just let them go at it, and then they are all consumed and you feel good because they're doing coding, that's bad actually. The reason why is because I've noticed a lot of click happy kids coming into Baby and Blue. So in the after school program, I help teach kids on STEM as well. And I noticed that basically whenever they feel like they are doing computational thinking or coding, they would change one variable and they click run. Change the for loop from 4 to 5, run. Change it to right to left, run, right? So that's called click happy. It means that they actually don't think about in their head and expand their mind and brain's performance and capacity in terms of, if I start with step 1 here, where will I end up with step 10 down here? What teaches that better actually is playing chess with your kids, right? Playing Go. That's also why, our intuition before is actually right. Like, why did I sign up my kids for chess, right? Having that, interpersonal interaction, abstraction, computational thinking in that non-screen format will help them pace themselves and expand their mind in really thinking about what are the possible moves that my opponent will have. And the more they practice, the more they expand their neural network. You want to expand their neural network, not expand the computer's CPU.
Great, thank you, Mei. Glad that you put an age on it. So that's very helpful for parents in finding the guideline.
Yeah, I think that's
yes, very helpful. So Eric is another parent who thanks you for your STEM insights. And his question is, with all the examples and steps in experimentation that you mentioned, are you suggesting that the skills to research a specific topic or theme is getting more important in today's primary education?
I would say primary education is not about being based only specific in one theme and passion. It's about making the connections between that one passion and one theme to real life, to science, technology, engineering, and math, and really making those connections. So if you think about my examples of just even about my daughter telling me the story of checking out where did the board come down to the China building, I was saying that that's actually a mathematical skill of comparing ratios, the size of me to the size of the board. And I think it's important for parents and educators to realize that, is that when you think about a passion that your kid really loves and allowing them to run with it, that's fine, because not one single passion that I know of can exist by itself. It actually naturally, in the process of researching about it, learning about it, its history, who are the famous authors in that topic, why are they famous, what are the comic strips that come out of that, why are there, what is the projection of that topic in the future, like I have students who are totally into the periodic table, right? But then that is not a specific memorization in itself. It's about how do you link the chemical properties of something to, real life stuff, like why are diamonds and charcoal made of the same thing, and one is way more expensive than the other. That's actually part of the periodic table learning. So it's definitely not eliminating breadth, but learning how to learn the way how our brain learns in terms of connecting the dots, in terms of neural network, right? If I think about carbon, I think about diamond. I think about diamond, I think about charcoal. I think about charcoal, I think about pressure. Why would pressure create diamond from charcoal? So following that will touch upon STEM naturally. The key is just don't stop them when they keep asking you why questions. That is when you end up giving them only a piece of the puzzle instead of the whole picture. And a skilled teacher would be the important part in terms of how to abstract the complicated ideas into simpler ones. For example, I would teach my kids why water must be H2O, like how hydrogen is like having two pairs of shoes, right? Can you ever walk with one foot? So having those metaphors, especially for like grade 4 or 5 students, help them remember and personify the characteristics of the elements in the periodic table.
Thank you, Mei. I think we can wrap up now with no more questions in the chat, and we're coming up to the end of the hour. I want to thank you so much for your time and energy in preparing this talk and sharing all your insights. I just want to wrap up with a quote, your own quote, which I really love in answering the question of what is the focus of primary education. I think it is so much about what you said in terms of cultivating their curiosity, right? And instilling in them this attitude that you say STEM as an attitude is to ask questions that no one else has asked before, to look for improvements when there are no problems, and to innovate when no one asked you to. I think that's the perfect summary of what we're trying to do at Bloom for our STEM program. Would you say?
Yes, yes.
Okay, well,
Okay.
thank you,
Thank you.
everyone. Oh, go ahead.
No, I just want to offer you guys that you can always find my information on bloom.edu.hk as well as Baker and Bloom. So feel free to email me any questions or any advice, I guess. Yeah.
That's right. That's right. Well, thank you, Mei. And now we will end with a video, but you're all welcome to depart as you're ready to. Thanks, everyone, for joining us.